Igneous is
Dun-dun-dun-dun-dun.
bliss.
Hi, and welcome to the 53rd episode of Igneous is Bliss. Today we have a very handsome and successful guest, Daniel Lee.
Thank you. Very happy to be here.
Pleasure having you on. Now, Daniel, could you possibly tell me, why do you find the topic of early Earth so interesting?
Well, I'm glad you asked. The early stages of Earth's life is filled with all manner of complications that have bamboozled most scientists.
What do you mean by bamboozled?
Well, during the Earth's formation, it was heavily bombarded by asteroids which destroyed most means of data that could be collected, as well as leaving Earth a molten rock for approximately 500 million years.
How violent was this bombardment period?
Well, to put it in perspective, the Moon was created in this period by a Mars-sized body colliding with Earth and ejecting material into orbit.
Me, that is quite the impact. If this is the case, why can scientists still age the Earth if it was damaged so much in that time?
Good question. We have a brief range on the Earth's birth through dating rocks such as zircons, lunar rocks, and chondrites.
How does this help the dating process?
Well, when the Moon cooled from its formation, it didn't become geologically active nor gain an atmosphere. Therefore, mechanical and chemical weathering were almost non-existent. This allows for rocks to stay alive for a very long time, moreover allowing scientists to date the birth of the Moon.
With all these conditions, what is the age of the Moon then?
The Moon is as old as 4.53 billion years old.
Okay, so we've got the earliest age the Earth was born. What is the latest? How do we indicate that?
Well, using chondrites, we can tell the age of the solar system, which is 4.57 billion years old.
So we have a brief range then.
Indeed we do.
You briefly mentioned zircons. What do you mean by them?
They have helped define the range even further.
How so?
Well, zircons contain uranium and lead, which go under the process radioactive decay.
That's the idea of half-life, correct?
Lastly, using the half-life of the contents, we can track back to when things such as the production of lead from uranium.
And whereabouts are those zircons found?
They're found in multiple places, but the oldest ones have been found in Jack Hill in Australia, that go back 4.4 billion years.
Fascinating. Could you possibly tell me the eras after the birth of Earth?
Of course, this era is known as the Precambrian, which is divided into two eras, the Archean and Proterozoic. The Archean is a period of time in which the Earth cooled until 3.9 billion years ago, as well as continental and oceanic plains started to form, and the first signs of early life.
Did plate tectonics occur at this time?
Within this era, yes, through accretion. However, the age of which this process started is widely debated by scientists. Due to metamorphism and erosion, almost all evidence has been destroyed.
You mentioned earlier that the Precambrian was divided into two eras. What is the other era, and how was this change in era distinguished?
The way the two eras are divided is with the Great Oxidation Event, occurring about 2.5 billion years ago, which is when cyanobacteria started to form and photosynthesize, producing oxygen which flooded the atmosphere and diluted the methane and nitrogen, thus starting the Proterozoic era.
Why is this oxidation event the turning point of eras?
Well, after the event, simple life started to flourish. The cyanobacteria started to form stromatolites. However, they started to decline in population due to eukaryotes.
I imagine that the Proterozoic era has more to it than just life, correct?
Indeed, the supercontinent Rodinia started to fracture to later become Gondwana, and in Australia, multiple economic cratons were formed, such as the Gawler, Kimberley, and Curnamona.
And how do these cratons form?
These cratons form through a process called rift sag, which is where the continental plate splits, and through isostasy, the centre fracture sinks, either forming an ocean or undergoes intracontinental sedimentation.
How do you know that these cratons were formed in the Proterozoic era?
The process Snowball Earth took place and deposited large tillites throughout the cratons, as well as finding fossils that were alive at the time of the Proterozoic, such as morsanites.
Well, thank you, Daniel, for taking this informative and concise interview.
Thanks for having me, it was a pleasure.
Well, that's a wrap. Please tune in for next week's episode where we'll be covering Elena Belosuda's hunt for zircons. I'm Priyanka Bhaktawansi, and this has been Igneous is Bliss.
Tune in next time on Igneous is Bliss.